Hello everyone. Wish you all a very warm welcome to the seventh session of OWASP Patna. Today we have with us Viraj as a speaker who is also a core member of OWASP Patna. Viraj will be giving a session on Thick Client Pentest where he'll be exploring the modern approaches and techniques. Viraj is a security professional with over 4 years of experience in VAPT, software composition analysis, and source code review. Viraj is also a very successful bug hunter with Hall of Fame from several reputed companies and also two CVEs in his name. Hello, Viraj. How are you?
Hello, Alia. I'm good. How are you?
I'm good as well. We are really excited for your session. I think we are good to go.
Great, great. Thanks, Alia, for such an introduction. And let's start. Okay. So today purpose of this presentation is nothing but the knowledge sharing, and where I will be giving overviews what the thick line pen test is and what are its test cases, followed by what the things we need to do while we get a thick line pen test. Right. So let's start. Thick line Thick line pen test, modern approaches and technique. Present by me, Viraj Mota. Next, come to the next slide. Today agenda we have set introductions followed by prerequisite for the things we need the things which we need while testing the client pen test. Then followed by the interceptions of traffic using Echo Mirage, followed by other test cases. Then there are scenarios where the privilege escalation we will be performing today. Then there are a couple of test cases abuse remember me functionality, followed by DLL hijacking, and the last model is zero-day POC, which I have recently found. So let's go to the basic. What is thick line? To make it more interactive, right? So yeah, the question is what is thick line to the audience, right? So could you just come up and share your scenarios and your idea? What is thick line?
Application which is running on the desktop or a system.
Okay, that's great.
It gets installed. It has a registry files, and then it runs in the system memory.
It runs in the system memory. Okay. Thanks, Satyan. So Thickline is an application that's run on a user host machine or a system that communicates with the backend server or a database. So Thickline, in a simple terms, we can say it is an application or the software installed on an Windows machines or the exe-based softwares that are used basically the softwares. It might be the Zoom, Chris, or we can say any thick line, even the Bob suite, right? And the Bob suite, right? So it even the thick line application, right? So okay. So this is nothing but a thick line application, right? And this thick line applications, then we can say the security perspective comes in picture where we will performing the testing on these thick line applications, right? So this is the definition. This is the examples of Zoom, Chris, Bob suite, and there are a couple of thick line applications, right? So let's go to the architecture side, right? So basically, these declines are classified into two types: two-tier and three-tier architecture, right? So okay, so two-tier architecture is nothing but the client and server architecture, where it is like the communication is happening directly between the client and the server. There is no, we can say, the middleman or the app server, right? And so direct communication take place between the client and the server. There is no intermediate between the client and server. Okay. So basically, where the client itself, we can say where it handles the presentation and the business logic, where the server handles the logic and itself the database, right? So this is the two-tier, and the next one is the three-tier architecture, where three-tier architecture basically here it comes the web server part, the middleman part, where it handles all the, we can say, the operations and the logic, and yeah, basically the logic part, right? And there is a dedicated the server side, the DB side, where it handles all the database queries, right? So three architecture is a well-established software application architecture that organize application into three logical and physical computing tiers: the presentation tier, user interface, application tier, and where where the data is processed, and the data tier, the last tier, the third segment, where the data associated with the application is stored and the managed. So the question is, how do we identify the we can say the application is two tier and three tier. So once we the thick line pen test or the project comes to us, right? So there are a couple of ways. Either we could ask directly to the developer whether this application is two, three, and three tier, right? And so that is the first way. This is the first way. Second way is we can use Ecomirage to intercept the traffic, right? Why we can use Ecomirage? Because in Ecomirage, if this is if the application is two tier, then there are the more chances where we could see the data query itself when we intercepting the request via Ecomirage. Whereas in the three-tier architecture, there will be the scenario where we will see this type of request where we can say the get slash uh, then we can say followed by the path, then HTTP and authorization. So these are nothing but the three tier, whereas in the two tier there is a scenario where mostly we will see the database query itself, right? So we can say the two-tier architecture is nothing but the insecure architecture where there are chances where we can see the sensitive details related to the database which we can see in the we can say while intercepting the request itself. That's why we used to recommend the client or the developers to switch into the three-tier architecture. So these are the basics between the 2, 3 and 3 tier of Ecomirage. Let's get into Pentest mode. So the first thing comes in picture, right? When we see the Ecomirage and post it, and when we want to capture the request, right? For the web, we have a bug suit and there is Zap server and there is other things, right? But in the case of the client, how do we intercept the traffic? So basically, we use Ecomirage to intercept the traffic in the thick line application. So Ecomirage enables intercepting non-HTTP traffic between a tested thick line and a local or a remote server. Intercepting requests using this tool give insight what kind of data was transmitted between the client and the remote server. So Ecomirage can hook into the tested thick line application processes so that communication between the tested application and the local can be intercepted, right? So there are the rules which we need to set in a Ecomirage. Let's get into the practical one. Let me show you the practical of this where we intercepting the request itself. So so Ecomirage is already installed into my system, and let me show you the rules which are set. Okay, so these rules are nothing but we need to go to the traffic. We need to set that direction. Any addresses asterisk, which means like anyone, right? And once we have set this thing, we have to click OK. And there are two ways. We are so here I've set the target is scripts. Let me open that application. Okay, so this is our target where I need to intercept its request. So there are two ways we can intercept the traffic. Not there are the two ways to intercept the traffic. Either to inject the running application, we could go directly to the crypts and we can inject itself from its processes. So this is the first way where we need to find the crypts. Right, this is the crypts. We need to click on OK. Once we go to the Krebs application, and in order to intercept the traffic, okay, so I have click on this part. So this is nothing but it refreshes, it goes to the server, and here we can see the request itself is captured in a Ecomirage, and here we could find there are the I think the same way in the web application, right? The request where the get authorization barrier token, where it passing the token, there are a couple of headers followed by the other headers, right? So here we could analyze uh, what the things are going into the server side, right? Okay, so this is the first way uh, where we have captured the request while running the application. So okay. So another way here we will inject the running process. Another way sometimes the echo mirage sometimes I think when you start testing the decline and when you try capturing the request, sometimes you might fail to we can say intercept the traffic using this method. So there are other way we could do is like we could click on this part. We could go directly to the exe part where it got installed, right? In the case of Chris, where we could go to the particular part. So here we will get where this exe is installed. We will copy this path, and what we will do, uh, we will go to this particular path. We will click on this scripts since we got the location, and from here itself we could run and we could capture the traffic itself from here only. So let's close this, and once we click on this, the scripts will automatically run and keep loading. And here also it's ready to inject. Okay. So this is the another way. Another way to capture the request from the e-commerce itself, right? Okay. Here the first test, the first thing is like we able to capture the request, and where we will see what things are going to the server side, and we will also identify it is a two-tier or a three-tier architecture depending upon the request is going from a client to the server end. Okay. So next go to the second So let's see the common test cases, right? So there are the common test cases which we will see which are present in a thick client pen test. Some of the test cases is nothing but the lack of code obfuscation. So if you heard about if you have done we can say the mobile pen test, right? So there also we will see the test cases or related to the lack of code obfuscation. There are the tools available to decompile and we will able to see uh, whether the code is obfuscated or not. So the same thing in the thick client pen test. So there are the tools present to do the same thing. So there is the for .NET application the DNSpy and ILSpy. So let's get into the practical one. So DNSpy, ILSpy, there are the many tools which are used to decompile the .NET application. So sometimes I do have DNSpy, ILSpy both because sometimes the application react differently and the both applications have it dependency. So it is better to if we failed at one point, we need to try the different approach or the different tools, right? Okay. So let me delete all this thing. Okay. So this is the IL spy and we have a target DVDA. DVDA is nothing but a damn vulnerable thick client applications which we are using today to basically to identify what are the weaknesses in a thick client pen test. Okay, so the things for these test cases, the things are very simple. We have exe, we have a tool. All we need to is like drag and drop, and what we will just we can say extract the properties, and we are here we could able to see that we are able to decompile and we are able to see the information uh, present in a exe. So this means the lack of code obfuscations issue is present here. And yeah, so the remediation to this part is like use the proper and definitely the logic behind is like to implement the proper obfuscation, and there are a couple of tools like ProGuard and other tools also present for the thick client pen test code obfuscation part. Next, move to the next test cases, the hard-coded sensitive details, right? So when the term test case comes in picture, right? So we will click, we get the insight, right? This is something the hard-coded present in our thick client exe or the server, right? How do we get those details? How do we gather those details and identify what the sensitive details are behind? So this is the interesting test cases where uh, the string dot 64.exe the tools are the part of this internal suite. So basically, these tools help us to extract the Unicode or the ASCII code of, we can say, of the application itself, where we will basically it fetches the data of the client, where we will able to find some, if there is some sensitive details within a DVDA, we are able to find it. So let's get into this. We have our, we will use the same vulnerable application.
For interrupt you, sorry for interrupt you. What CFF Explorer is used tool is used for the also I used tool is used for the information gathering.
Correct, correct.
Yeah.
So, okay, okay. So CF, since I have told, right, there are a couple of tools do the same work. So we can say the CFF Explorer, right? Basically, these tools give we can say the what type of architecture behind it, and it also gives the other information what the framework is present in a thick line. So there are various tools, right? So I'm
Okay, thank you.
the tools because it will make you more like confusing, right? So there are various to do the same purposes, right? The command is simple. We have set a string rexe, and we have set r, we can the target application, and we will just click we will just enter the payload, and we will see what the things. So these are the nothing but a bunch of information which we extracted, and here if we see clearly, right, so we are able to extract the sensitive details like the password, right. So there's nothing but there are the chances. So this is the demo, or this is the, we can say, the vulnerable application, whereas in the real world, right, where you guys got the application. So these are the test cases which will give definitely one step ahead, where if some sensitive detail present, it will just extract that thing and it will give you. So here we will able to find the password part. So next test case is SQL injection. So SQL injections vulnerability, it is the same in the web, where the attacker itself entering the, we can say, the query, SQL queries, try to balance and break the queries, then bypassing it in order to perform the action. Either it, we can say, bypassing the login by modifying the queries. So there are the various things. So this test case comes in the client itself, where I have performed the similar actions, where we can see in the login page, the user and the password field and the login button, right? And here, where I have entered, we can see the balancing the queries, where I have bypassing it by using the payload single quote, or single quote one, or single quote equals to single quote one, single quote, and followed by in the same thing in the password field. And once we have entered this thing, the we are able to bypass, and we are able to log in as a Raj user in the second thing, in the second POC, right? So this SQL injection, the injection itself, the same thing which we have done or doing in the web pen test, right? So I believe the most of we have done the web pen test, right? So I think the same thing which we have applied, which we need to apply in the thick line pen test. Next, move to the interesting vulnerabilities, right? The memory analysis. Since we are aware, we are using, this is the something the thick line pen test, right? And where the application save its data somewhere, right? It might be, we can say, sometimes it might stores in some particular file. There are a couple of files like which we have to look in the thick client app code, and there are some, we can say, they have created in the temp folder, they have might created some sensitive details, or it might store in the memory, right? So this is the another interesting test case which we have to look after in the thick client pen test. So memory analysis is a critical test scenario that enables an attacker to analyze sensitive data within a system memory. And so once we get to know that there might be the cases where sensitive details might save in the memory itself. So there are the tools present uh, to find the sensitive details in the memory itself, and if we will see if any sensitive details are present or not. So this is there are the, interesting tool, process hacker. So we are using the process hacker here, since there are many tools I have mentioned here already, which somewhere works the same way to extract the information. Since the work is same, but there are how many tools? The four tools doing the same work. So here, for the presentation purpose, I am going with the process hacker because it seems like it's look cool to me, and it's I think does the same work for me. So here, once we open the process hacker, we have our target, the DVTA, and what we need to do is like we're taking the scenario where where the victim have login using the admin and the password, and we however we get the lower privileged user into the systems, and we get into the process hacker, and however we need to find what sensitive details are present in the memory, and so that we could extract it and we could leverage it into the further attack scenarios, right? So for these we get into the process hacker. We have to select or double click on a tvta. We need to go to the memory part, the memory tab here, and we will go to the string, and here we are taking the scenario of username is admin and the password is sensitive because it is masked, and we are not able to see it, and it might be stored somewhere, right? And we are taking that scenario, and we will checking if any sensitive data is present in the memory or not. So here in the string we will set the minimum length, we will set the 10 because we want more than the 10 characters, includes some confidential data or some sensitive data. You could we could customize ourselves here. So for now I have set the 10. I'll click on OK, and it give me the result, right? You could see there is so much, we can say, the dump of data, right? So there is one more thing which we could do. We could go to the filter, then again to the content, and we will look for the similar, we can see the pattern uh, in the normal scenario where we will go with the search by user or the password, and we could go to the, quickly we can click on it, and we could see this is LG password, and this is thing, right? Okay, let me just click on this login. We could see this is not the sensor details here, it is showing it is different, right? Let me click on login, and I believe it will save in the memory, right? Let me show you that part, that is the interesting part. Okay, it throws the error, but however it goes to the server end, right? And here we could see the password is bigger, right? Here more than, we can say, more than these characters. Okay, then what I will do, I will go do the same step, go to the string, set the minimum 10 characters, again filters, look for the sensitive details like the password, and here you could see you found the password here. So what we will see, the the thing what the application does, so the DVTA application stores the password in the memory itself. So this is nothing but this is not the expected scenario which we could expect the developers to do. This is the insecure way to storing the password in the memory, because anyone could access the memory, however getting the privilege, definitely getting the privilege into the physical access, right? Then there are the cases where this shouldn't be happened, right? So this is the one of the scenario where we will see these sensitive details are stored in the memory itself.
Hi Viraj, can I ask a question?
Yes, go for it. Yeah.
If it is running in the memory, if we are storing, what is the reason why it went to the memory in the programming?
Okay.
How it was mentioned that it went to memory?
Okay. So you are asking why the developers are stored in the memory, right?
No, whole application will run in the memory only, right?
Okay. Mm-hmm.
So any variable you declare, you use for a password field to store
Correct.
that password will go in memory only. Any program you see,
Correct.
it is there in programming memory. So what you need to do? Why it is
Why it is
uh,
a vulnerability?
right? Why no, not why it is a issue? What need to be done where it will not send to the memory?
Root cause of the vulnerability, right?
Yes. Yeah. Exactly.
Let me take in the way, right? Why okay, so why the developers use the RAM memories to store or basically to store the password and the username? So I have seen the scenarios while performing the testing. There are the cases where the developer are use the user and the password they allow to store in the memory. Why? Because every time we can say the application or every other functionality, the developer used to told me, or we basically used to told me that tell me the scenarios where for every authentication or for every other function he required, there is a, we can say, there is a need, right, where it requires the every in every other step he required the user and the password. So to uh, we can say to easy these steps, right, what he does, so he does basically stores the sensitive details in the memory itself. So every time the application don't have to ask for the authentication uh, to the uh, to the customers, right? So what he does, like he just store the sensitive data itself in the memory, right? Then okay, that is, we can say, the case where the developers let this happen, but there are the things which the developers have to do, and the cases where I have recommended and they have done well, right? So there are the steps, or there are the remediation to, we can say, avoid, if they required, right, or to use the sensitive details from the memory itself. So there are the cases where I have seen that developers, they have masked the sensitive details, we can say, in the case of password, right? So either they have masked or have encrypted, right? So there are the two things they can do. They can perform the encryption, we can do some kind of encryption, or uh, where the encryption they could perform, and which make it attacker difficult to, we can say, either to decrypt or might be able to find it, right? So this is the first case. Second, what the developers have done, it's like mask the, we can say, sensitive detail itself. Mask in the sense, right, the half data we can see the password, and the other things we can see here masked, right? So there are the things which he have done, and why the root cause of this is like something the developers are using this technique to avoid asking again login to the, we can say, to the customers, right? So I think this is the first channel where the developers avoiding the more steps, they are using these things to avoid asking re-authentication. Where the second thing, which the remediation is definitely is in place, where we could avoid this thing by using the masking and the encryption part. So if you ask me in the coding perspective, I think the developers might be, they have the more, we can say, the insight. All we can give is like logic, right? What things we have to done. Is that your answer?
Yeah, Viraj, it's fine. Yeah, thank you.
Great. Okay. So memory analysis, right? Yeah, definitely there's a remediation in place, like we call it mask. So this is the scenario, which we can say in the 0 day. This is the scenario where I have found the license key itself in the memory, right? So this is, we can say, not the silly word is like the lazy work which the developers have done to avoid or to use the proper encryptions or something, and that is the one of the, we can say, the scenario which I have found, or the license key in the 0 day, which I will show later in the slide. So once are we good with the memory analysis, let's go to the next part, privilege escalation, right? So this vulnerability, it's like seems very interesting, and it have the high severity. Although this privilege escalations we are aware, let me give you the introduction to these privilege escalations, where we, this is the vertical scenario privilege escalations, where the normal user performing the admin functionality, and however in the case of horizontal scenario, horizontal privilege escalations, where the normal one user is performing, we can say, performing the actions, whereas the second user having the different privileges, but however the first user performing the, even performing by using some bypass, even performing the user 2 functionality, that comes under the privilege escalations, where however we can say the user privilege have been increased and it has been escalated, where it performing the more action that than he than the, we can say, the permission he have assigned, right? So that scenario comes in the thick line. So basically, today I'm presenting the beta fast software. Basically, it is another the vulnerable software where we are taking the scenario. There is a normal user and there is the admin user, and in the normal user, we could see there is, we can say, normal user have the functionality to home, shopping cart, settings, and logout, whereas the admin have functionality uh, more than two more functionalities, where it admin related functionality, when it could modify, it could add the user itself. Okay, so today I am presenting the demo of this. I have created a demo on this beta fast. Okay, so the tools which I am using is Snoop tool. Basically, Snoop tool basically gives the there is another decline tool which give insight which we can loop uh, to the beta fast or the target application, and we could go to the properties and we could even inspect and we can modify some permission in the property itself by using Snoop tool. So this is another decline tool which will be amazing tool, and definitely it gives a good result. So we have a beta first as a vulnerable application. We use the Snoop tool, and this is the tester is nothing but our normal user. We're taking the scenario of the normal user, and we need to privilege escalate into the admin. We can say the admin role. Okay, let's get started, right? So here I'm logging into the application, and here I have drag the tool, we can say the beta fast into the Snoop tool. Here we could see the Snoop tool where I have set the beta fast here. I have logged into the application. Here we could see the four tabs: home, shopping cart, settings, and logout, right? Which is expected by a normal user. Then there is a things comes in bigger picture, right? Here we will go to the properties using these settings. We go to dip into more properties. Then there is a section which we will find if any properties or sensitive details are present in an application, right? So we will go to the grid part, uh, and in data context. Okay, so we will go to the data context, and here we will see the admin visibility is hidden. Since we get access into this, what we will do is instead of hidden, we will manually drag to change it as hidden to the visible part, and we will click on this and we will see how the application reacts. Once we have clicked on this, you can see in the right side we got the two more menu items. This is nothing but the admin functionalities we are able to get it, right? And since we get into the user management, the next thing which we do in the Pentest is like the user maintaining the user, right? So what we will do, we will create another account using the admin role. We will give it as a test username test, the password is test, first name test, and we will see here we will give it as a role admin. And once we will log out and we will try check the things are working or not. We will again try to log in and see where we are able to leverage from normal user to the admin user. So, okay. So let me tell you the scenario. These scenarios are very rare because I have, since this is the vulnerable application where I've seen the scenario, but other case I have not yet found this scenario. We can say in the corporate world because these scenarios are very rare. But this is the another test cases where we could leverage from the privilege normal user to the admin user. We could do the most stuffs, right? Since we got into property, there are more things we could do. Let's go to the another vulnerability, abuse remember me functionality. So this functionality seems very interesting. We uh, we have seen the remember me functionality in the web application pen test, where these features allow user to store their login information on their local computers, allowing them to skip the login process when coming back again to the website. So this basically to abuse the remember me functionality, there is another test case which we will look after in the thick client pen test. Let's do this practical way. Okay, so there is an interesting tool we could use here is WinSpy. So what does WinSpy does? So WinSpy allows the user to view the mask data, right? Which what basically what we want, right? So since here we could just take a scenario. We are taking the scenario where the username is admin and your password is your password. Okay, I have said the password is your password, and since it is a mask, and however when we can say there is the functionality within the thick client where every time when once we click on remember me, it saves the user and the password, right? When someone users open it, the user and the passwords remain there. So this is the WinSpy tool, amazing tool to find what information is going in the mask. So we will use the WinSpy, and this is the easiest method to do uh, is like drag and drop to the particular path where which we have to see the information. And see, once we get into this part, there is a WinSpy, we drag and drop, we are able to find the sensitive details, we are able to unmask these sensitive details like the your password. So this is the another test cases which we could see after in the Thick Client Pentest. Using the WinSpy tool is amazing tool another. Okay. Let's come to the interesting vulnerability, DLL hijacking, right? So I hope like the most people are aware about DLL hijacking and its impact, right? And if we have heard, like if we like, I am sure that the previous test case which I have shown, some might have here, some might haven't here, but this DLL hijacking, it's like it have the different fan base, right? So let's get into this DLL hijacking. So DLL hijacking happens by placing a malicious DLL in a directory which is then located by the application instead of a legitimate DLL. This causes the malicious DLL to load with the same privilege as the application, thus causing a privilege escalation. So this is DLL hijacking is nothing but we can say every whenever if whenever applications misses some DLL files, or we can say due to some like missing the absolute part, right? Then in the cases of the attacker create a malicious DLL, either he will replace, we can say to the we can say the legitimate DLL, or either he could place the DLL in the place where the we can say the system searches that particular DLL. We will get into the more into the we can say in the POC part. So let's understand how the DLL works, right? So suppose some exe applications having the supporting DLL, which is required, we can say having some properties, functionalities. When we run the exe application, we will see it calls the supporting DLL files to run along with it, right? So that comes under the scenario where how the Windows performing the DLL search pattern, right? So suppose there is a thing where DLL is not present in a current directory. So what the system does, what the we can say the OS does, right? So system follows the pattern, right? So this is the predefined patterns how the DLL search order works. So the first thing is like it will look where it will look in the install folder if that particular DLL is present or not. Then if he didn't, if the system didn't found anything, it will go to the system 32. Then it will go to the system. Then it will go to the Windows followed by the search order. Since these are the particular directories which are defined by our system how the DLL search order works. Then next thing we need to understand how the DLL works. The next thing comes the save DLL search order pattern. So this is we can say one of the interesting thing which came after the Windows 10, which it has some inbuilt DLL order search. So we will get into the more into this part. How let's get into the DLL hijacking and how we are able to create a payload and we are able to execute and we are able to get the reverse shell. Okay. So here we are using the our DVT time enable application to perform a DLL hijacking on this part, and we are using the procmon to monitor uh, we can say the processes and how the exe the which file the exes are calling. So procmon, the tool we use to identify which the application DLL making the calls, right? We can see the how the exe making the call to a particular DLL. So using procmon, we will identify which DLL file it goes looking after in a particular directory or the particular file. This will give insight what where we have to replace our malicious DLL with. And here we could see there are a couple of DLL already present in our folder DVTA. We are like I'm just able to log in into the application. I'm able to log in like using the view expenses, add expenses, all this I'm able to performing the functionalities. Okay. Next, let's start the procmon. So before running the application, we need to start the procmon. Procmon is nothing but process monitor, and these sections are very important. Basically, these are the nothing but the filters which give us the result to look at the particular path. So instead of looking every each other file, right? These are the filters which we need to set. So if you see clearly, the one of the filter I have set the process name is dvta.exe. The second thing which we are interested is result is name not found. And the third thing which we have seen the path ends with DLL. So if you take all this scenario, you will get the insight or you will get some hint what we are doing next. Okay. So we have set our filters. We will click on apply and okay. Once we have done that part, we will again go to that particular DVTA. We will again try to run it application to run the application. Since we started getting the result itself, so we will again try to log in into the application. And what we are doing is now we will try each and every other functionality. Why? Because there are some DLLs which, if taking a scenario, some DLLs might be used when we use the view expenses. So we are just doing all this stuff, right? And here we will see the in the POC we have found the couple of DLLs, right? We get a list of DLLs, and what the information which we are interested is like these DLLs name not found, and it is the part of DVTA application which making the call. And if you see the file tab, right, it goes to the framework, it goes to like every other path, right? So these we are interested, and these are nothing but our target where we could replace malicious DLL with one of these DLL files, and we are taking the missing DLL which the DBTA tried to call, but however the legitimate DLL is not present. Since we get the DLL, what we will do? The next step is we will create we can say the POC. Yeah. So next step is like we need to either we could create a calculated malicious DLL which do the work like of calculator some for the demo purpose, or we could get even more to get a reverse shell as well, right? So this is possible in the DLL hijacking. So since I have already created it, the calculated payload. So for the demo purpose, I'm using the calculated payload here and have created the file. All we need to do is like rename that particular file exactly with the same name which the DVTA application is calling. We will replace it. We will rename and we will replace to we will see where this particular DLL are making the calls, right? So it is better we could go to that particular path and where we will replace that particular DLL file. Since we have put our malicious DLL here, so uh, yeah, so we have put the malicious DLL here. So every other time when the victim clicks on a DVTA applications exe, let's see if it call making the calls or not. See, we are able to we will try logging into the application. We click on login, and there we go, our payload got executed. So the exe make call to this secure 32.dll, and it where the payload our payload got executed, and we are able to uh, generate a calculated payload itself. So yeah, DLL hijacking is the interesting vulnerabilities, and there are remediation in place to avoid, we can say, the DLL hijacking. So we could suggest developers to follow the secure coding guidelines or the practices, and the next thing is like specify the exact location of all associated DLL files to prevent the Windows from defaulting it's to DLL search path protocol. Keep antivirus AV up to date. And there is the automation tools available, DLL Spy, which this is the defenses tool which search for the malicious DLL. or the crafted one, and it will be it will detect us the detect the victim if any malicious DLL modified or replaced, right? So since we have done all this manually, right? What if I tell you we could do this all in the one go in a we can say the automated script? So there are the scripts present: impulsive DLL, hijack. So this is the interesting tool which recently I have came across. So this tool, what it does, since we use the procmon, we have to use procmon, we have to replace the malicious TLL, we have to set the we can say rules in the procmon, right? So this tool does all in the one go. So the payload is very simple. We need to select the impulsive DLL hijack, and here we have to give our target application. Okay, so the command is very simple. We have set exe and the we can say the target application. I have to give the path. Okay, it automatically run the procmon. It will overwrite. It will we have to click yes. It overwrites the results. It asks for the login. We could enter anything here. It will again ask for the procmon. It existing. It runs it behind, right? And this tool is amazing, right? See, if we see the result, right, what the things which we are getting, right? So here we are able to find, it will list out the potential vulnerable DLL path, right? And these DLLs are nothing but where the attacker or where we as attacker we could replace any malicious DLL here, right? So here we could see it again traces this particular DLL which we have recently seen the demo where we have replaced this thing and we have able to execute, right? So identity identified, and the next step is to exploit, right? So this DLL already we need to we can say we could configure this particular tool even more to perform to create a DLL and to perform an action, right? So since we have copy and paste this DLL here only, so this application does all in the one go. Once we have configured more to perform these actions, right? So the prerequisite check. This is nothing but our malicious DLL. If we have set that particular DLL here, it will perform the actions. So this tool is amazing tool where it gives the pre-configured results. It gives the list out the DLL files. It perform action on our behalf. So this is the automation stuff. There's since we are getting the more the cybersecurity, there are every other tools. The we can say the tech is our building, right? So it will make us easier to perform the action. Next, not a list. So the 0 day POC, which I have recently found. Okay, I got you found like you got some hint, right, where I have found this particular CV, right, or the 0 day. So on it is on the precision breach. So this is the one of the interesting tool, we can say the corporate tool, where it allows it allows we can say from one platform to another. It allows the communication between them, and it sync it between from one to another, right? So it is so basically to give the insight, right, what I have found. So basically this vulnerability is something where I have bypassing the precision breach license key validation mechanism itself. So normal scenario should be every so once we can say for particular software the one particular key is assigned, right? In the case of Bub Suite, right, the particular key I have assigned, can if we can reuse that particular key on our system, either the two scenarios should be expected. So either it will not allow, it will check, it will say that particular license belong to this system, or if we use that particular license key in our system, then the first one, uh, we can say the license key get revoked, right? So there are the two expected scenarios which should happen, but in our case we were able to use the one particular license key many times. How? By bypassing the MAC filter. We are finding there is an attack chain proper. We are finding the uh, sensitive details in the memory itself. So let me tell you the attack scenario, and they have the so this is the critical business impact. The severity is very high because they makes these we can say the millions of $1 million using their softwares. How, what if we you can use same license key every other person, right? So it will make lot of losses for them. So this is the description which I have gave to them, right? The attacker able to change the vulnerability of disclosing the victim MAC ID bypassing the MAC ID validation itself. Okay, so this is the scenario where where we can say this is the victim A and victim B, right? Where there is this how they are binding, right? We need to understand how they are binding. So the license key is assigned to, we can say, the user A and the user B. So the user here have requested or paid some amount to get the license key, and that particular license key is assigned to the user A, and where we could see the user gets some kind of licenses which will be binding to the MAC ID. Let me like highlight this point, right? Every license key, normally the developers what they do is like binding the license key to the MAC ID, right? And however, if another user try to enter that particular license key in their system, it will throws the error, right? Which is expected, right? Because the MAC ID of one doesn't match the MAC ID of second user, because both MAC ID is like unique, right? So here we will getting the error where it discloses the license host ID was not found on this machine. So here we will get an insight if the server is checking the host ID or the MAC ID of current system, so that the particular license is assigned to particular MAC ID. But the things which we have to highlight, which we have to notice. So here, if you see clearly, right, we are able, there is one more information is leaking, right, the MAC ID itself. So the thing is like here, from here, the attack chain is happening, right? So from here, the MAC ID itself, the server in the we can say in the error, right? The server is disclosing the MAC ID of the victim itself, and which MAC ID, the one which the license key is assigned to it. So since we get the license key, since we have now the victim ID, the next step is like we have to modify our the attacker's MAC ID, right? And which is possible. So since here it was observed that the attacker not able to use the same license on other system due to validation which they have placed, and note that in a error message the MAC ID of system A is disclosed, right, which we have seen. Next step is like how we could, since we get a MAC ID, we get a license key, how we will get replace this thing. So there is the automation approach as well as the manual approach, where we go to the device manager, Ethernet connections, locally address administrator address, insert our values, right? So we go to this particular path. What we here we have to set not our MAC ID, we have to set our victim MAC ID. And once we have done that part, we go to the, we can say the we can say the network and the administrator path. We have to disable the all other, we can say, the adapters. Anytime the server making the call or the client making the call, right, the client will check that particular thing only in the place instead of there are so many things. So here I have replaced, uh, I have inserted the victim MAC ID, and here when I did the IF config, it is reflecting, right? Here it is reflecting. So earlier it shows like the my previous MAC ID. Once I have done the changes, now this thing it is getting reflected. Now when I tried again to apply the license and use the same license, I'm able to do the same stuff. And here we can see the product is licensed, and the evaluations license is 5 days remaining. So and even I'm able to perform all the actions like the paid software, how the paid software works, right? Able to perform all these actions. So this is the interesting vulnerability, and we are like there are so many things which we can focus by bypassing the MAC. If we get a MAC, we could bypass. We could have to see what the errors the server is throwing. There might be sensitive details which we could find, right? And there is one more thing, the license key, right? So the question is like how where the license key comes in picture, or where we have found the license key. So license key which I have found, it is in the memory itself. The memory part which we have seen here in the memory analysis, right? This is the part, right? So I've done the same step in the case of where you have found the password, right? In the same scenario, the lazy developers, what he have done is like he used the memory to save the sensitive details in the memory itself. So once the application was running, taking a scenario application was running and get into the system, use the process hacker to get into the memory string and look for the sensitive details where I have found the license key itself present in there. And from there, the scenario have started where it is uh, disclosing, we can say the MAC ID, then bypassing the MAC ID. And on the base on that, they have assigned me the CV. Yeah. So this is the CV which they have assigned, I think last December only on my name, right? Yeah. So, so
One question here.
yes,
So this license key is available in the memory every time you run the application, or in the first installation when you did, let's say when you
every time,
install.
every time.
So whenever this software runs, this license key is available in the memory.
Correct, correct, Satya. So
Okay.
I'm not sure how they, we can say, configure behindly, but every time the application runs or we perform any actions, at that time the license key is present in the memory. So I have told you, right, there are some things which the developers are might be lazy because they used to store the sensitive details in the memory. So every time they have to perform, so they don't ask the victim to re-enter again and again. So I think
Right.
such scenarios make them easier, but however, these scenarios will make more potential vulnerable.
So have the client they have
Yes.
fixed this
Yeah,
in
yeah,
your.
yeah. So yeah, so they have these things and they have put the remediation in place. So
What was the fix what they
correct, correct.
implemented?
Yeah. So, so there are the many fixes here. If you see the POC, right, there are the many things. So this is the proper attack chain, but there are the many things. We could see there are many vulnerabilities. First is disclosing error. Second thing is storing the sensitive details in the license key, and the third thing is like the MAC binding bypass. So the first scenario, what they have done, so in the memory itself, they have started masking since I have recommended and this I have already seen the scenario in the previous assessment of the company. So I have told that particular remediation it is working and they have put the same thing where they have now started masking the license key in the memory itself. So there is a logic, we can the set of scripts running from their end which are working, we can say in the client side code, which are working to bypass mass particular sensitive details. Next, the fix to make it more impactful. The next fix, what they have done is like this particular disclosing the sensitive details, right? So here also we get the if if we didn't get the MAC ID, right, it will again make us or me difficult to performing the bypasses, right? So again, the next fix they have put where they have like avoid disclosing the sensitive details like the MAC ID in the error message. This will allow attacker to basically to guess this particular MAC ID, right? Until and he does the MAC or you can say the brute force or some script running behind. So this will make an attacker or the attack a little bit difficult. The third fix, the interesting fix they have put is like uh, so since we have seen the bub suite type, right? In the bub suite, where if we can't use the two licenses at once, right? So this is the another interesting thing which they have put now. They have if someone the next user tried entering the we can say MAC ID or we can say MAC ID, and if another system is making the call or try to apply, right, it goes to the server, and server it allows, right. So every time what they have put, so every other time we can say every other system is making the call to the server. So in the second time they have either to follow the procedure where they have to send out email where giving the detailed explanations why they have to change the license or they have to enable the license on another system using the same license. So they have put the procedure or the email procedure. So I think that thing they have put in place now. And yeah, so this is the chain of attack which the remediation they which they have put in the we can say in the latest version, right? Yeah. So this Thick Client pen testing is interesting, and there are many test cases present, right? And this Thick Client is very interesting topic, right? So there are many things we could explore, and there are many tools, right? I think one of the audience tool like CFF or Explorer, right? There are many tools which does the different work, which does gives the different output, right? So yeah. So yeah, I think I'm done from my side. Yeah.
Thank you, Viraj, for such an interesting knowledge packed session. Your session really helped us understand thick line pen testing and its major techniques. Thank you, everyone, for joining us today. OS Patna extends heartfelt gratitude for your time and sincere effort. Thank you, everyone, once again.